The nephron is an essential microscopic structure that's found in the kidney. It's responsible for filtering the blood and regulating the amount of substances in the bloodstream in the process of homeostasis. There are about 1 million of these in each kidney. The nephron is made of a number of essential parts. The first is the Bowman's capsule. Then the glomerulus. Next comes the proximal convoluted tubule, or PCT, the loop of Henle and the distal convoluted tubule, or DCT. And finally the collecting duct that drains into the ureter and the bladder. Now let's zoom into the glomerulus. The blood entering the glomerulus capillaries are at extremely high pressure, and this means that most things are forced out of the blood into the Bowman's capsule, such as ions, urea, and glucose. However, larger molecules such as proteins are blocked and don't get through due to the basement membrane. This membrane is fenestrated, meaning it has lots of holes such that smaller molecules like ions and glucose can pass through, but that it blocks larger molecules like proteins. This filtration of substances at the molecular level under high pressure is called ultrafiltration. The next part of the nephron is the proximal convoluted tube, or PCT. Here, all glucose is reabsorbed through active transport. And as you can see, those green blobs of glucose are being pulled out of the PCT by those blue protein pumps. The PCT has a number of adaptations. For example, it's long and coiled, which increases its surface area. It has active transport proteins in order to move the glucose from the nephron into the bloodstream up a concentration gradient. And all of this takes place in the process of selective reabsorption, where certain molecules like glucose are reabsorbed back into the bloodstream from the nephron. There is a higher concentration of glucose outside the nephron than inside the nephron. So to move glucose out, we must move it up a concentration gradient, which requires active transport and active transport proteins. The next part of the nephron is the loop of Henle, where water and ions are reabsorbed, helping make the urine more concentrated. As the filtrate moves down the descending limb, the one on the left, water, those blue blobs, move out of the loop of Henle by osmosis. And on the ascending limb on the right, ions are pumped out by active transport, leaving less water, less ions and the same amount of urea as before. The reason for this is the increasing salt concentration as we move down the loop of Henle from the cortex to the medulla. Next is the distal convoluted tube, or DCT, that really is very similar to the PCT, reabsorbing any other ions or substances that need to be reabsorbed. The final part of this fascinating structure is the collecting duct. Here, more water is reabsorbed into the bloodstream, leaving behind urine that is ultimately emptied into the bladder and excreted out of the body. But what controls how much water the collecting duct reabsorbs? Well, the answer is in antidiuretic hormone, or ADH. ADH is secreted by the pituitary glands in the brain and increase the permeability of the walls of the collecting duct. This allows more water to be reabsorbed into the blood, and typically means more concentrated urine. When you are dehydrated, the hypothalamus in the brain detects a lack of water in the blood, and so stimulates the pituitary gland to secrete more ADH. This increases the permeability of the collecting duct, and so you reabsorb more water. The opposite happens when you're overhydrated, with the pituitary gland secreting less ADH. These holes in the collecting duct are called aquaporins, that only allow water to pass through. To conclude, the nephron is an incredible structure in the kidney that filters and cleans your blood through essential processes like ultrafiltration and selective reabsorption. We hope you enjoyed this video, and thanks for watching.